Good morning, everybody. Today is Tuesday, September 20th, 2022. My name is Man, avoiding his apartment move and procrastinating many times. And in that vein, today we are back and we're going to work on some more Elixir on Exercism. And today we're going to be talking about agents. So we'll go right into the concept documentation. The agent module facilitates an abstraction for spawning processes and the receive send loop. From here, we call processes using the agent module, agent processes. An agent process might be chosen to represent a central shared state. To start an agent process, agents provide the start function. The split function, when starting the agent process, returns the initial state of the process. In this example here, you call agent.start, you pass in a function with the initial value of an empty list, and you get back an agent inside of an OK tuple. Just like map or list, agent provides many functions for working with agent processes. It is customary to organize and encapsulate all agent-related functionality into a module for the domain being modeled. So, and then I give you some links to more documentation. So we've got the agent documentation here. On the Elixir website. So basically, they create an agent, and then they call agent.update. They pass it the agent, and then they give it a function. The function accepts the state that the agent is managing, and then it returns a different version of that state. In this case, they're going to prepend the string eggs to the list. They can call get agent, and they'll get the state, and they can call agent.stop to just stop it. And so, when we talk about this, when we talk about state, it's important to remember that, there is no inherent, immutable value going on. This is functional programming, and the reason this works is because, inside of a process, they're using recursion to kind of listen for this mailbox loop, and then it's just passing the state as the initial value of all those functions. So it's kind of holding the state, but it's not state in the normal object-oriented way. Cool. All right, so we're going to work on Community Garden. Your community association has asked you to implement a simple registry application to manage the Community Garden registrations. The plot struct has already been provided for you. Okay. So let's dismiss our tip of the day. You can edit smart selection regular. You can edit smart selection regular expressions in the preps one. Okay, that's good to know. And I'll open this in VS Code. I was playing around. I continue to goof around with extensions and stuff in between episodes. So some of this might look a little weird. So yeah, you can see this thing run test, run, show in. What does run do? Run test. Show in test explorer. Show log. Interesting. Okay. We're gonna close that for now. And these still work. We still have our stop signs there. So if I run test explorer, run all tests, it'll run them all and they'll all fail. And yeah, you'll get some output down here. Okay. Does that output always show up when I do that? I don't remember it doing that before. Interesting. Log main. No. I don't remember it doing that yesterday. It's weird. Search. Problems. Alright, I am wasting everybody's time here. Okay, so we'll get going here. And I gotta open up the README. So we'll open up the README down here. No, I want the readme. Okay. Okay, open the garden. Implement start. It should receive an optional keyword list of options to pass forward to the agent process. The garden's initial state should be initialized to represent an empty collection of plots. It should return OK tuple with the garden's PID. Okay, so that should just be as simple as agent.start, and this is going to take a function. Doesn't get an argument, does it? No. So the initial one is an anonymous function with no arguments, and that'll just return the list. And let's run this test. Undefined function. Oh, no, that needs to default to an empty list. All right, cool. So that passes. So it's interesting. So I'm like mixing test extensions here. So like when I hit run test, this is called a code lens. And so it's running the code lens and it's putting it in here. But this right here is part of the test explorer. So that's different. So like if I have to run the test explorer, run all tests to actually see to see the little green check mark over there. Okay. All right, I'm gonna make that smaller. I don't want that jumping up on us. And I'll say this too. Typically, when I work by myself, not on camera, I usually take the terminal, I put it in a different window, and I run like mix test.watch, and so it just like runs the tests all the time through there, and that way like my editor kind of stays static, doesn't kind of like move around a lot. I don't really care for this moving around, but for the purpose of recording, kind of do what we have to do. Cool. Okay, so the next one is number 2. Implement list registration function. It should receive the PID for the community garden. It should return a list of the stored plots that are registered. So that should be agent.get, and the first thing will be the PID, and then the second thing is going to be just the function, right? So get accepts state and just returns the state. Yeah, so that's just going to be list and we'll run all the tests, and those look green, so that's good. And then we'll do number 3, which is multiple stuff. Registers plots to a person. Implement the register function. It should receive a PID for the community garden and a name to register the plot. It should return the plot struct with the plot's ID and person registered to when it is successful. Some of the English there is a little weird. It should be incremental and unique. You can keep an ID counter in the state. Oh, okay. You can keep an ID counter in the state. Interesting. So where the tests they're running, can register a new plot, maintains the registration of plot. First plot has an ID of 1. Does that mean the second plot has an ID of 2? Yeah, they're like 1, 2, 3. Okay. The reason I'm like curious is because like they say the IDs should be incremental and unique. You can keep an ID counter in the agent's state, but like they've already kind of predefined the state as a list. And so, I mean, I could definitely build a function that like when registering a new plot, it accepts the list and grabs the number. I guess you can just do that because you always know that if you're always adding to the head of the list, then you know the last one added was the highest number of the stuff, so that shouldn't be too bad. Okay. So let's say agent dot update, and that's going to take the PID, and it's also going to take the function that does state to state. So function list, and so what we want to do is if the list is empty, then we want to make it with number 1. If it's not empty, then we'd want to prepend it with that. So let's say next ID equals there's a couple of ways you can do this. The simple way is just use an if statement. Be like if can you do empty? List.empty. Enum dot has empty. I think you'll get a warning that do else. So if it's empty, you do 1. Otherwise, you'd want to capture the first item. Most recent plot list dot first, and then you'd say you'd grab the ID, so you'd say most recent plot dot plot ID. Is it plot ID? Yeah, plot ID plus 1. And then you just return the thing prepended. So you could definitely send it as a. So you got plots. What's the name? Is that what it is? The plot. The registered 2 is the key. Register 2, and then plot ID is going to be next ID. And then that is going to be on top of the list. What is this complaining? Oh, I'm doing Atom twice, and then I need a comma there. Alright, let's run the test and see what happens. So these are all failing. Okay. So run test. Key error registered to not found. Did I spell it wrong? I did. Registered to register to. Oh, they're using different. I was sabotaged right there. Run all tests. They still fail. Okay. So we'll run the test, and it'll fail. Oh, why does it fail? Because I need to take care of the return. It should return the plot struct with the plot's ID and person registered when it is successful. Okay, so we're supposed to return the plot. Okay. So let's change this up a little here. So we'll do this outside of the agent update. So the first thing we'll do is we'll get the list registrations for the PID, and then we'll do the next ID. Next ID, we'll do it inline right now. We may pull that out into a separate function. And then we'll construct the new plot, and we'll make this consistent. So we'll say new ID. So new ID, and then up here we'll just put in the plot there, and then we'll return new plot. Agent update. What does that return? That always returns. That just returns OK. So we're gonna pattern match this against an OK. So that way, if this fails, this will crash. And we would want that. We don't want it to fail silently there. Okay, so that's passing. That looks good. And we'll move on to number 4, because I'll clean that up later if I want to. Implement release. It should receive the PID and the id of the plot to be released. It should return OK on success. On success is interesting. When a plot is released, the ID is not reused. It is used as a unique identifier only. Interesting. So this is ruining our the way we base our IDs. Because right now, if we do a thing where we release a plot from the list, particularly if it's the first item in the list, then we can no longer count on it, count on the getting the new ID based off of the top of the list. So, I mean, typically what I would do in that case would be, I would change the state. The state wouldn't be a flat list. The state would be like a map with basically a dedicated attribute for the next ID. So that way, changing the list would never affect the next ID. But I don't think I can do that because they are dictating the shape of the states that the agent is managing. So when a plot is released, the ID is not reused. I'm trying to think of how I would solve for that. I mean, I can't change the shape of the agent state, and I can't just grab an ID from the top of the stack. That's frustrating. It's weird. It's weird because this thing says the test is already passing. I don't know how the hell it's already passing. Do not reuse the thing. So it creates the garden. It registers Keanu Reeves, Thomas A. Anderson, plot 1 and 2. Then it releases 1 and 2. Oh, it's passing because I haven't implemented release. They need to add another assert here. They need to add an assert to validate the list is empty. I might make a PR for that. Because that should not pass. Alright, implement the release function. It should return the PID and id of the plot to be released. It should return an OK on success. When a plot is released, the ID is not reused. It is used as a unique identifier only. I don't know what they want me to do. I mean, I can change the mutate. Like, I guess the point is that like I am not like I'm never leaking the internal state. I mean, you kind of are here, but I don't know. I'm gonna solve this by changing the state because I don't know of any other way to do that. So, um, so we'll just this will just be a map. This is gonna be a map, and it's gonna be next. Next ID is just going to be, it's going to start with a 1, which basically, and it's going to say plots, and I don't know why they say options up here, but I'll keep it as ops. I would call that plots, not ops. I guess I can change that because they don't care, right? So that's going to be plots, and then when you want this, it's going to the initial state plots. It's going to return the plots. And then this one, this is going to get list registration. It's using the word list. I'm going to use the word list. Initial list. Initial list looks better. Initial list registration is going to come in like this. And then they're going to say register to. It's going to grab the list. And I don't even need this anymore. Yeah, I'm gonna add a function called nextID, and it's gonna accept the PID, and it's gonna get the it's gonna return it. Next ID equals, and this is important because you know, if I had refactored, then I'd be like, that would have been premature refactoring. All right, so okay, and then so when this thing happens, this is actually going to take both parts. This is going to take the list and the next ID. I guess I don't need to grab it there because it'll always grab it there. So I might be able to get rid of that. I'm just gonna comment that out for now. And so this is gonna return the next ID is going to be next ID plus 1, and then it's going to create the list with the new plot prepended to the head of the list. And I don't need that anymore either. I can get rid of all that. And the new plot, you're not happy. Why are you not happy? Oh. Well. Alright. I'm going to assemble the plot in there, and then I'm going to get this feels really weird though. it feels really weird that if register is supposed to return the plot, that like I'm creating it in here and then I'm getting it up here. Like that's making an assumption that during this time no other plot was inserted, which in this case, of course, will be fine, but that is a little weird. All right, let's make sure that we didn't break everything. So let's see what's passing. So task 3 is still all passing, which looks good. So now for release, now finally coming back to release, it's going to accept the PID and then the plot ID. Okay. Agent dot update PID, and then it's going to be a function, and it's going to be that state, and then we add to we actually don't need the next ID, we just need the list. Returns a list with a replaced value. That's not what we want. Remove. See, the thing of it is it is a it's a linked list, so you know, removing delete deletes the element. It deletes the given element from the list. Returns a new list without the element. If the element occurs more than once in the list, just the first recurrence is removed. Okay, that looks like what we want. So list lot delete. We'll say list, and we want to remove well, we can't. We don't know the form. We don't know the exact structure of the plot. So maybe we need to enumerate through it, like filter it. Probably. Reject is probably appropriate. Returns a list of elements and excluding those for which the chunks are returned. Yeah, that sounds like what we want. This is not going to be very performant, but that's probably fine. Plot. So this is going to be this rejects truthy. So we want plot ID. When plot ID equals the given plot ID, we will reject it. New list. And then we need to return, I guess we do need next. Yeah. Well, we'll do it. Next ID, next ID. If you had a lot of state here, it would get repetitive to type all that out all the time, but that's fine. So the new state of the agent is going to be next ID, and list, and new list. And what does release need to return? It needs to return OK on success. That should be fine because this is going to return OK on success. All right, let's run our test. Cool. So let me recollapse these. So we've got task 4 passing, and then we've got task 5. Implement get registration function. It should receive the PID and an id of the plot to be checked. It should return the plot if it is registered and not found if unregistered. Okay. So yeah, I would just get list equals list registrations. List registrations, and you pass it to PID. And then I mean you use enum to find it. Right? I mean that sounds appropriate. Find value. Similar find returns the value of the function invoked instead of the element itself. Interesting. We're not really dealing with the edge case of the fact that like if there's more than, if somehow the plot state gets weird because there's like multiple ones with the same ID. We're kind of making that assumption, but I think that's fine. So we can do a case enum dot find, and we'll give it the list, and then we'll say function plot plot dot plot ID equals plot ID, and then we'll do if it is nil, we'll return not found. If it is a plot, we'll return the plot. Let's run all our tests. And they are mostly green. Return not found when attempting to get registration of a unregistered plot. Not found. Why is that not found? It'll get the list. The list will be empty. If you run enum find with an empty, if you run enum find with an empty list, what does it return? Run test. Oh, not found plot is unregistered. It's kind of weird. It's kind of weird that they expect not found in other failures, but they want that explicit one there. Oh. It should return the plot if it is registered and not found if it is unregistered. Oh, they do. No, they say it right here. I was reading based off of the English description of the number 5. I thought they just wasn't the atom, but if you look at the example, they do. They show an error tuple. Okay, so we'll use an error tuple. No problem. Okay, cool. So everything's passing now. Are we happy with this? This is probably my most sus part of the code. Getting the new plot from this seems really weird. It feels like you should assemble the new plot up here, then just return it, but to do that, then you'd have to introduce a next ID function, which probably would make sense. I'm going to do that because I think it's less weird to do a next ID. I think it's less weird to introduce this new function than to do what we were currently doing. So this is going to accept the state with next ID, and this kind of like abstracts the implementation a bit too. Like the fact that we were capturing next ID down here and we had to define it down here, it felt I'm gonna say next ID plus 1. So that'll be the new plot. And then That'll be a new plot plus plot ID +1. Or no, that'll just be next. Yeah, so now you don't need that anymore. And then you can just return a new plot. They didn't ask for this, but I feel like that's the best way. I don't know. I'm a little confused because I feel like in some ways it almost sounds like they don't want us to keep that as part of the agent state, but we'll see when we look at the community solutions. All right, let's run these one more time. They look good. And then we'll run Exercism submit lib, and we'll check the robots. The robots have something to say. The public interface code should be carefully considered. Yeah, it doesn't like the fact that we introduced that. I'm fine with that. I'm gonna leave it. Alright, so let's see how they solved this. So they got agent, so plots, index, yeah, so they kept the state there. And get an update. Oh, so they used a different function. Agent, get an update. Gets and updates the agent state in one operation via the given anonymous function. Start link starts the state with the number 42, and then it returns it. Okay. They also use agent.cast. Performs a cast, a fire and forget operation on the agent state. The function is sent to the agent, which invokes the function passing the agent state. The return value function becomes the new state of the agent. Note that cast returns OK immediately, regardless of whether the agent or the node it should be lived on actually exists. Interesting. So what did he do that for? Release. So accepts status. It's a weird word. I mean, the problem with status is it means everything. Any filters, any removes. Find. Oh, that's the default. If you don't find it, then it returns that. I feel like mine reads better. What other ones we have here? I feel like there's a lot of opinions here. Yeah, so he does next ID as well. I like the word next ID rather than index because that is more like domain specific for what it's actually doing. Put in. Okay, so that's how he's mutating the state. Yeah. That looks good. Yeah, they're all of these people, so like my thing of like register where I create the plot outside of the update and then I return new plot, like they're getting around that because they're using get an update, and so they are intentionally returning new DB. So just get an update. It's tough because they're in their example they only have Oh no, they have it right here. So the function get and update accepts the PID, and then inside the function, it accepts the state, and then it returns. You finish the function with a tuple, which is state, and then state plus one. State is what's returned, but state plus one is actually going to be what's stored. Okay, that is a more appropriate solution. Okay. So let's change our thing here. So let's do that. So we will next ID, and so we will call get and update. And so what's going to happen is we've got our PID. It's going to accept the current state of the agent. We're going to generate our new plot. And then what we're going to do is we're going to return a tuple with a new plot, and then the new state of the agent. And then we can just return that. And then we can get rid of this. And that should work. Let's run all the tests again. All the tests are passing. Let's submit our solution. The robots should be a little happier. Yes, the robots are happy. And I am happy, and hopefully you are happy. Alright, so with all that done, I'm going to mark our stuff as complete. We're going to publish all our iterations, and we have learned the agent concept. Cool. That unfortunately does not unlock any new things for us, but agent is good concept to have. We're going to learn more about versions of the process. So process is like, you know, we learned processes back in up here. A process is a very like low level fundamental concept of the beam that Elixir runs on, and then you'll discover that the Elixir and the Erlang stuff underneath of it provide some abstractions that handle common concerns, like the first one being agent, and then later on we'll learn about gen servers down here. There are other ones too. There's one called task, which I don't see task. Oh, there it is. Yeah, so task is another one of these abstractions built on top of processes, but we will get to that later. For now, I want to thank you for watching. Hopefully you enjoyed the video. If you have any questions or feedback, please do let me know. Other than that, have a great day, and I will see you next time. Bye-bye.